Hello everyone and very warm welcome to you all to the questionnaire round. Here we are going to discuss the JEE main pattern exercise related to purification and characterization of organic compounds. So I hope everybody is ready for the test. So let us just move on to the question number 1. The distillation technique most suited for separating glycerol from spent lye in the soap industry is. So first of all, let us just analyze what the question says. So they are asking about some kind of distillation technique, and what we have done so far is different kind of distillation techniques which are given over here. So suited for separating. Now we need to separate glycerol from the spent lye. What is this particular thing? Glycerol from the spent lye is basically nothing but the saponification reaction. And the spent lye is basically what? This spent lye is the alkaline glycerol. What is this alkaline glycerol? When the fat is converted into, saponified into what? Saponificated into the glycerol along with the soap naturally. So what is left in the mixture is glycerol along with the soap, that is alkaline mixture of both, that is known as the spent lye. So we need to separate it out and we need to take out the glycerol as a whole. So for that purpose, if I go for the simple distillation, so that would be a cumbersome process because simple distillation would be requiring lesser temperatures. But if we go on to the boiling point of glycerol, so I would like to tell you over here, the boiling point of glycerol is approximately 290 degrees Celsius, right, which is quite high. So simple distillation will be unable to achieve this much of temperature easily. If I go by fractional distillation, again it would be a very improper method. Steam distillation if I go, so steam distillation also, it must be having some immiscibility with the steam, with the water, and that is not possible over here because glycerol is soluble in water, right? So here all of these three methods will be wrong, but distillation under reduced pressure, which will actually reduce the boiling point of the glycerol, and now glycerol can easily boil off, easily separated. So that is what the answer over here is. Distillation under the reduced pressure. So we need to reduce the pressure of the entire reaction mixture, reducing the boiling point of the glycerol and separating it out. Clear? So answer is D over here. Let's move on to the next question. Very next question. What does it say? A miscible mixture of benzene and chloroform can be separated by, so I have given a lot many techniques here. So let us just analyze first what benzene is. Benzene is a non-polar compound, right? Whereas chloroform will be polar. But they are saying over here is a miscible mixture they have taken. That means they have taken both of them in such a quantity that they are miscible with each other. So there is no point of sublimation because sublimation is solid to vapor conversion, right? So here both of the things are in liquid state. Chromatography, again we are not sure about what kind of adsorption will be there on the stationary phase. Crystallization, what is crystallization? We need to first dissolve it into some solvent, but these are itself liquids. So how can that be possible? And now comes up the distillation, and also I would like to tell you a point over here in crystallization is, if I have got a liquid only and then I boil off, then I heat it out with some kind of solvent, what will happen? If I then try to cool it down, again I will be getting the liquid and not the crystals. So the condition for crystallization is we must be having what? A melting point, right? Melting point higher than the room temperature, right? So that is how we can obtain some crystals at room temperature for that substance. So this crystallization is also not applicable because here both of them are liquids. Benzene is a liquid and chloroform is also a liquid at room temperature. Now comes up the distillation. So if I look at the boiling points, boiling points of benzene, so it will be around 80 degrees Celsius, whereas for the chloroform it's around 60 degrees Celsius. So there is a difference of 20 degrees Celsius boiling points. So right, we can apply, we can take out the method of distillation for the separation, and to be very precise, I can also use the method for fractional distillation because the two boiling points are closely related, right. So I can have, to be very precise, steam distillation, sorry, not the steam but the fractional distillation over here, and thereby the correct answer is D. I hope everybody has got it. Now, let's move on to the next particular question. In the Lascine's extract, now the question comes up for Lascine's test. For the detection of nitrogen in the organic compound, the appearance of blue colored compound. So, what is Lascine's extract? For the detection of nitrogen they are asking. That means Na plus C plus N will be giving NaCN. That is the Le which is formed, Lascine's extract, and this is then used for the detection of nitrogen. The appearance of Prussian blue color compound is, so they are asking about basically the Prussian blue, what is that compound. So we need to have a proper knowledge about the reactions, what are the reactions involved. So the reaction is NaCN will be reacting with the ferrous sulfate ions, that means Fe2 plus ions will be giving hexacyanoferrate, right, and this hexacyanoferrate will then be reacting with the ferric ions. Why they are reacting with ferric ions? Because due to the addition of sulfuric acid, concentrated sulfuric acid, it has converted some of the Fe2 plus ions into Fe3 plus. So there will be a reaction between Fe3 plus as well, which will give this particular compound. So if you look very carefully, this is nothing but having +3 state and +2. So it will be ferric, and this is ferrous, right. So this is ferric, this is ferrous, right, or I can say ferro, right, a short form. So if I just compare the options over here, ferric ferricyanide, ferric ferri means +3, which is not possible, right. Ferrous ferri, that means +2 first and then +3, also not possible. Ferric ferrocyanide, yes it is possible, +3 followed by +2 state, and ferrous ferro again +2, which is not possible. So I have got my answer over here, that is C. I hope everybody is able to follow. Now, let's take up the next question. Again the Lascine's test, but here with silver nitrate they are asking, right. So where is the silver nitrate used? It's used for the detection of halogens. So is commonly used to detect the halogens such as chlorine, bromine and iodine, but not useful to detect fluorine. Here comes another unknowledgeable question for you. Not useful to detect fluorine. Why? Because the product AgF formed is, definitely the product will be AgF which will be formed. So here AgF formed is volatile, reactive, explosive, soluble in water. So what option it could be? So if you see over here is AgF does not form the precipitate. So that is the main thing, because what we obtain in detection of halogens is AgCl, AgBr and AgI. All of these are insoluble in water, insoluble in water, right. That is why they are forming the precipitates. So that is quite a simple one. Do not get confused in all the options, because how do we detect the formation of the silver halide? By its precipitate. If the precipitate is soluble in the water, then how can we detect? It will not be visible. And if the precipitate comes down, it settles down, it's not soluble in water, we can easily very well see by naked eyes, right? So That is why option D is correct over here, that AgF is not able to get detected in the solution because it is already soluble in water. We do not get a precipitate for that. Clear or not? Now, let us move on to the question number 5. So, we have reached halfway. Correct pair of compounds which gives blue coloration precipitate and white precipitate respectively. So, they have been given two reactions over here. We need to figure it out, what kind of reaction is it. First, they are saying it is giving blue color or blue precipitate. Second, they are saying white PPT, right? So, respectively, when their Lassigne's test is separately done, definitely the two tests have been separately done. So, what are the two tests? First, we need to figure out that, and then I can choose my options very easily. So, where do you get the blue PPT or the blue color? It's quite a simple one, that is the Prussian blue color detection for nitrogens. So, that is Prussian blue detection for nitrogens, detection of nitrogen. And where do you get the white PPT? That is the detection of halogens, right? And what kind of PPT do we get? That is for the silver chloride. So, here it will be white PPT. We get it for the halogens, to be very precise chlorine, and that too AgCl, right? So, we need a chlorine in my compound, in the second one compound, and in the first one I need a nitrogen and a carbon. Clear? So, if you just observe the options quickly, in the first option, for the formation of NaCN, I need Na, I need C, I need N, right? And this NaCN will give the Prussian blue color. If I do not have a carbon in the compound, I cannot get this Prussian blue color. So, this makes the option incorrect. Also here if you see there is chlorine, this will definitely give the test for halogens. But here the entire option is incorrect otherwise. NH2CSNH2. Here what do we have? We have got a thiourea. In thiourea, if you just observe, it's sulfur present, and whenever the sulfur hinders into the test for nitrogen, we get a blood red coloration and not the Prussian blue, right? So, this is also not giving the test. This will give the test. It has got chlorine, but otherwise the option is incorrect. So, I have got two incorrect options, NH2CH2COOH, right? And the urea. What do you observe over here? This will definitely be giving the test. NaCN will be formed. Here in the urea part, you do not have any chlorine. So, this will not give the white PPT. And now the last option. I have got the nitrogen, right? I have got the carbon. I can get the sodium cyanide, which will then give the Prussian blue. If you observe over here, I have got chlorine as well. So, this will definitely be giving the white PPT also, and this the blue color, thereby making this option the very correct one. Clear? So, I hope everybody has got each and every option properly. So, that is how you need to analyze each and every option. Do not just guess the answers, but try to find a logic behind each and every one of it, right? Now, let us move on to the sixth part, sixth question. For the estimation of nitrogen, 1.4 grams. Okay. So, that is the estimation for nitrogen. What kind of a method is given? That is the gel-Dahl method. Quite an important one, as I told you. For the estimation of nitrogen, the organic compound weight is given. The evolved ammonia was absorbed in 60 ml of sulfuric acid. So, the evolved ammonia entirely was absorbed by 60 ml. How much? So, it is H2SO4, the total H2SO4 that has been taken in the conical, remember? So, that will be 60 ml. And what is the molarity of this standardized sulfuric acid? It's M/10, right? Or 0.1 molar you can say. The unreacted acid required 20 ml. Here what has happened is this entire acid has not been consumed, right? There is some part left out, some unreacted acid. So here out of 60 ml, some unreacted has been there, and this unreacted acid required 20 ml of NaOH solution, right? The titration we had performed earlier in the Geldahl's method. Okay, so here it is titrated with m by 10 NaOH solution, right? And how much of this solution is required to neutralize this unreacted acid is given out to be 20 ml. That means if I just write the equation for this titration, I will get the value for the unreacted acid. Let us see how. NaOH will neutralize H2SO4 and we will be having what? Na2SO4, right? So if you just look here very carefully, what do I have? I have got, right, Na2SO4 and along with the water. 20 ml this was. Now if I just try to properly balance the equation, what do I get is twice of this, right? Now you can check very well whether the number of oxygens and here, okay. So it will be a hydrogen over here or something like that. We are not concerned about it, but what we are concerned is about that H2SO4 neutralizes twice of amount of NaOH. So that is 2:1 ratio which is going on over here, right? So this says what? This tells us about the amount of unreacted acid. If the amount of H2SO4 reacted with NaOH is just half of NaOH, that means NaOH how much it is given? 20 ml. So the unreacted acid will be just half of it. So it's 20 by 2, that is 10 ml. That means this was unreacted. So how much H2SO4 out of the total was reacted one? So here the reacted will be, I hope everybody is able to correlate that. That is 50 ml, right? Clear? So this 50 ml will be reacted with the ammonia. Now I need to have an equation for ammonia and H2SO4 neutralization. So that will be NH3 plus H2SO4, right? And if you just look here very carefully, I need to make it twice again. Clear? What do we get over here is ammonium sulfate as my major product. So here again 2:1 ratio. That means the amount of H2SO4 that is required, ammonia will be twice of it. That means amount of H2SO4 that was reacted, NH3 will be twice of it, that means 100 ml, right? 50 into 2. So once we have got the amount of ammonia, we can very well find out the percentage of nitrogen, we can very well find out the amount of nitrogen here required. So it will be, if we say that 1000 ml of 1 molar ammonia will be corresponding to how much? It will be 14 grams of nitrogen, right? So 100 ml of m by 10 will be corresponding to 14 by 1000 into 100 into the molarity, that is 1 by 10. Clear? So what will it be? So it's 14 by 100, right? This much grams of nitrogen. Once I get the mass of the nitrogen, I can very well find out the percentage, that is divided by the total mass of the compound. That is given out to be 1.4 grams, right, for the organic compound. So here I am putting the values 1.4 into 100, right? So if I just calculate it, so what is coming out? It's 10%. Very easy, super easy calculations. So we get the answer as 10% and here we have got the option as well. that is C. I hope everybody is able to correlate with that, and I hope everybody is able to solve the question on their own. Now, let's move on to the very next question. What do we have? In the Carris method of estimation of halogens, so remember the Carris method? 250 milligrams of an organic compound gave 141 milligrams. So, the organic compound weight has been given to 250 milligrams, right? How much AgBr came out, was produced? It's 141 mg, right? The percentage of bromine in the compound, you need to find out the percentage of bromine in the compound. So, how do I find it out? So, it's quite a simple one. So, that means if I talk about 1 molar, that means 1 mole of AgBr, that is how much? That will be 108 plus 80, that is the molar mass, will be corresponding to 80 grams of bromine, right? So, this much amount, that means 141 will be corresponding to, and here if you look very carefully, it's given in milligrams. You need to first convert it into grams. So, that will be 141 divided by 1000 grams will be corresponding to 80 by 188 into 141 by 1000 grams of bromine. Once I get the grams of bromine, I can easily find out the percentage. So, it will be divided by the total mass of the organic compound. Again, I need to convert it into, yes, into grams, 250 by 1000, right? Again, a very easy calculation this is. So, what is the answer? You will be getting the answer as C. You need to perform the calculations on your own. It's simple multiplication and division. You will be cutting out almost all of it and you will be getting a precise answer over here. Now, let's move on to the next question. Right, again the Carris method has come up. In the estimation of sulfur by Carris method, again what is there is estimation of sulfur. Remember barium sulfate formed as the precipitate. So, this much amount of an organic compound has been given. It's now in grams, so no need to worry about conversion into grams. So, what we get is the barium sulfate, 0.699 barium sulfate, the percentage of sulfur in this compound. Again a similar kind of procedure. So, let us just do that procedure. Barium sulfate first of all, how much will be the molar mass coming out to be? So, its barium is 137 plus 32 plus 16 into 4, that is 64. What will it be? It will be 233 grams, right? So, we all know that 1 mole of, again a similar kind of unitary method followed. 1 mole of BSO4 will be corresponding to 233 grams of BSO4 will be corresponding to how much amount of sulfur? We need to find out the percentage of sulfur, that is 32 grams. So, we have been given 0.699 of barium sulfate which is formed. So, 0.699 grams will be corresponding to 32 by 233 into 0.699, right? So, this much amount of barium. If you just look here very carefully, it can easily get cancelled out, 1 and 2. So, that will be 0.002, right? Here we have got the grams. I am not completely doing the calculations. I will be doing it in the next step, which involves the formation of the finding out the percentage of sulfur, for which we need the entire mass of the organic compound initially taken, that is 0.480 into 100, and that is the percentage, and you can very well easily cancel out each and everything, not a long calculation but a smaller one. So, here what you are getting as the answer will be approximately 20%, 20 point something will be the answer. So, here if you just look the options over here, they are not very close to each other. So, I can have an approximate value over here of the answer, right. So, approximately the answer comes out to be 20 point something. So, it will be 20%, clear? Now let's move on to the second last question of the questionnaire. I hope everybody is enjoying the numericals. Yeah, a gaseous hydrocarbon gives upon the combustion this much grams of water, this much grams of carbon dioxide, the empirical formula of the hydrocarbon. Quite a simple one, but if you just read it very carefully, they are asking about, that means 0.72 grams was required, 0.72 grams was the water which was formed, 0.72 grams is the water formed, and 3.08 is the carbon dioxide which is formed. So if you just apply the unitary method, you can find out the percentages, the grams of H individually and carbon. Why I am finding out the H and carbon? Because here in the empirical formula, they are just asking about not the oxygen, but the carbons and the hydrogens, right? So we can find out the percentage and then we can easily find out the ratio of the two. So how we are going to do that? So as per again the unitary method, 1 mole of H2O will be containing 18 grams of water, will be corresponding to 2 grams of hydrogen. So thereby 0.72 grams will be corresponding to how much? 2 by 18 into 0.72, right? So which will come out to be how much? 0.04, that is 0.08, right? This much grams. Now if you come here, 1 mole of CO2 will be corresponding to, we know the molar mass of CO2 is 44 grams. If not, you can just find it out very easily. So it will be corresponding to how much carbon? 12 gram. So thereby 3.08 will be corresponding to how much? 12 by 44 into 3.08, which comes out to be 0.84 grams, right? So once we have found the grams of both of them, this is for the hydrogen, this is for the carbon. So I can have it for 1 mole as well. So I need to find the ratio of the two, that is carbon is to hydrogen ratio. It will be, if I convert this grams into mole, right? I need moles because I am considering 1 mole of that compound, that is the empirical formula says. So it will be 0.08, that is the mass, divided by its molar mass 1, right? And is to hydrogen, that means divided by the value for hydrogen, it will be 0.84, and again we need to convert it into a mole, so that will be a 12, right? That is for the carbon, the molar mass of carbon, and thereby I will be having what? So it is 0.07, 12 sevens are 84, right? So what will we get? We are getting 8:7 ratio, that is hydrogen is to carbon, not carbon is to hydrogen, here I am getting hydrogen is to carbon ratio. So they are asking about carbon is to hydrogen, that will be nothing but 7:8, right? I hope everybody is clear with the idea. That was quite an interesting question also. So the answer is A right here. Let's now move on to the very last question of this questionnaire. So what does it say? Okay, here comes up the question for chromatography. The separation of the constituents of a mixture by column chromatography depends upon. So they are asking about a principle of chromatography, that too column chromatography. What we have? We have got a stationary phase, we have got a mobile phase. Mobile phase contains the components, what we need to separate. Then the components move along with the mobile phase into a column. They get absorbed as per their different what? Either the solubilities or boiling points or refractive indices or adsorption. So basically they get attached due to the affinity, attached with the stationary phase, but not completely absorbed but attached on the surface. What is that term called? That is nothing but adsorption. Absorbed on the stationary phase, and that is how they get stuck as per their different affinities, as per their different attractiveness towards the stationary phase. and that is how the components get separated in the column chromatography. So, I hope everybody remembers the principle for the column chromatography. That is quite an important one also. So, thereby we get D as a correct answer. So, that was all under this questionnaire round. I hope everybody has enjoyed it, and if you have got any confusion, you can just revise and go through all the questions once again, do the calculations on your own, try to perform it on your own. So, I will be back with the JEE advanced exercise in the next session. Until then, have a very good day.